Hello, lovely people. Yeah, finally it is time to test the amplifiers. So in the previous few weeks or a month or so, I was testing DSPs and everything else about their performance. I was testing the audio interfaces and everything. And now it's about time to start to test with amplifiers because I have loads of amplifiers to test. I have this one, I have the older Alpine, I have old school Alpine, and I have some really bad ones. So let's go through the equipment because it's quite a lot. I did made a few videos about how I'm testing my amplifiers. And this is going to be a very short one just to show you how everything goes because I changed some stuff. And then we're going to go through all the measurements in REW and I'm going to explain basically what we have. Let's start with the source. The source is going to be REW going through USB into topping D10S. I will be running it at 96k kilohertz, just because why not? Then from topping via coax is gonna go into Helix DSP Pro Mark III. So we know how this DSP measures, and we know that this DSP measures much better than the amplifier, and we know that this is gonna have a good signal going optical with no problems at all. This measures like minus 100 dB, which is, amplifiers are not gonna touch it for sure. So the amplifier that I'm testing today is an Alpine X-A70F. It is a 4-channel amplifier. It's rated at 120 watts per channel at 4 ohms and 175 watts into 2 ohms. Now, the power ratings for us don't matter. This is not an amp dyno. This is just to check the performance, THD versus frequency versus level and that kind of stuff. If you're interested in amp dynos, go somewhere else. This is not max power, this is actual stuff that really matters. Now, feeding everything is this lithium battery from Crown Customs. I have 2 leads, one for the amplifier and one for the DSP, because I know this is the cleanest power that I can get. This battery can supply up to like 250 amps or something. We have 235 amp fuses, so that's 70 amps max. Perfectly fine. A circuit breaker, if anything starts to smoke, it's a 100 amp circuit breaker, so it's going to supply the current needed for the amplifier. Now this is a load bank, which I have all these leads going in there, and I'm going to be testing at 4 ohms and later at 2 ohms. So this is all 4 channels loaded. Now, how I did everything on REW, minus 6 dB is the maximum signal that I'm gonna feed because minus 6 dB gives me 3.9 something volts out of this DSP. If I would go up to like 0 dB, then it's gonna be like 8 volts, 6.7 volts or whatever, and it's gonna be too much for the amplifier. The amplifier with the lowest gain settings can take up to 4 volts input. So 4 volts out, 4 volts in. Now, the gains on the amplifier, I turn them just a tiny bit just to drive the amplifier into clipping, a tiny bit of clipping, because when we're going to see the THD versus level, I want to see where it clips because I want to check how much power are we getting with 1% distortion and 10% distortion, just for fun. So I need it to be clipped. And then I have a current meter here that shows me the current that is drawn from the battery, and I have a voltmeter just to check how much voltage I'm getting. So just an example now, I'm playing, let's say, minus 10 tone. I have play. So I have a sine wave, clean sine wave. I have this measurement with, I'm not going to go now into this, but later after this. Then I have 15 volts out on the speaker levels. So this amplifier is supplying 15 volts. And we're drawing 36 amps of current with like fully loaded, all 4 channels fully loaded. Now, if I increase the level into clipping, which is, remember, minus 6 dB, we have clipped signal, we have 22 volts, and we have 57, so 60 amps of current drawn. I'm gonna shut it down because amplifiers don't like to clip, and this is getting warm when you clip it. So basically this is the setup, and now I'm gonna perform all the measurements in REW. If you wanna see what measurements I'm doing and how, go a few videos back. I'm gonna link the video in the description as well, and you can see how I do the actual measurements and what the measurements mean. And yeah, this is going to be very, very fun. Again, thank you very much for my subscribers on Patreon and people that donated to me directly via PayPal. I'm going to leave all the links in the video description. If you can donate $1, that's very welcome. If you cannot, that's totally fine again. It's no problem at all. So yeah, let me test some stuff and I'm going to present you with the results. While I'm doing the measurements, one quick note about the gear. So in the DSP testing, if you saw, I was using the topping and I was using a different AD converter, which was kindly lent to me by Adam. However, this is kind of high voltage, high amperage stuff. So I don't want to risk and by any chance damaging Adam's equipment. So that's why I'm using my own Focusrite interface. If anything is gonna blow, it's gonna be my equipment and nobody else's. So that's fine. But even this Focusrite, the other AD converter, the Cosmos one, it has like 10 dB or maybe even more lower floor noise and THD and everything. But again, for testing amplifiers, it's perfectly fine. It's not a DSP. Even for the DSPs, it's kind of fine. But for amplifiers, it's going to be plenty enough that there's no need to use a better interface than the Focusrite. Another note, because I forgot to tell you as well, so about this amplifier, all the filters are bypassed, so channel 1, 2, off. Now, this amplifier can be set to feed only 1 and 2 channels or all 4, so it's set to feed only through 1 and 2, so I have only 2 RCAs in, but I have all 4 outs. Okay, so change of plans. Again, I had to discard all of that because I was getting some noise issues and I didn't understand where they're coming from. I tested 3 different amplifiers and I'm getting the same just random noise stuff. So I simplified everything. It might be because there's no loopback. I'm not sure, but I simplified and I did everything like I did in the first video. So Scarlett out, Scarlett in. Gains on the amplifier just to match it because the Scarlett is going to give me 1 volt clean out and just gains up. Now the gains are, as you can see, it's like a third up just to match it. And now I think I'm going to get proper good measurements. So yeah, overcomplicating things, I don't know. It's probably due to like grounding issues because like you have 1, 2, 3, 4 grounds, potentially 5 grounds, and it's like, So yeah, keep it simple. Lesson learned. Keep it simple and just go with the flow. So I kind of did all the measurements. Now what I'm doing is I'm measuring everything in 2 ohms. So before it was a 4 ohm load, and now with this setup I can do 2 ohm load. So instead of grabbing pins 1 and 3, I'm grabbing pins 2 and 3. So instead of 4, I have 2 ohms. So on 2 ohm load, because it's interesting to see how THD is gonna be different with different impedance. We know there's gonna be more power, that's expected, but with CEG, it's going to be very interesting to see. So 2 ohm load test as well. One interesting thing that I want to show you is, so now this amplifier is loaded all 4 channels on 2 ohms, so it's the harshest that it can be. Now I determined from this graph that -4 dBFS is the highest it can play without clipping. So this goes into clip. So when playing -4 dBFS, if I play the tone, we have a 70 amp current draw. 70 amps over there. So this is the thing. When you start clipping this, and I guess it's the same with all amplifiers, if you would start clipping, actually we can start clipping. Let's go to -1. -1 dBFS, so it is into clip. It is there. -1, which is like probably 10-20% THD. If I play now, 94 amps. So the fuses are not blowing yet, but probably if you would play it for longer, the fuses would blow. So yeah, everything above this, it's clip. So it's very cool to notice and cool to know. Okay, let's do this. And the most important graph, at least for me, I don't know about you, but I love seeing this. So this is a graph
of total harmonic distortion versus level. And in this graph, we can see the actual total output and how it depends on the actual level. So the first part of the graph, which is here on very, very low level, on low signal, we have dominated everything by noise. You can see all the noise is here. And then after like, in this case, after like 20 watts, we have some harmonics popping in, like second harmonic, third is a bit lower, which is good to see, and that kind of stuff. So this is distortion that's coming in. So this amplifier, it is rated at, if we can have a look here, at 4 ohms, 120 watts, and 175 at 2 ohms. So 120, let's have a look. And it says 14.4 volts, below 1% THD. So it's not going to be like 100% the same for me, because I was testing at 13.2 volts, so lower voltage, and THD below 1. So let's find THD 1%. So on dBr is different. 1% is this line here, and this shows me 120. So 120 on the lower voltage, and if I would bump the voltage up to 14.4, that's more than 120 watts per channel, which is great to see. So let's have a look at this. The lowest, if we have a look at the lowest, the very, very lowest is something like minus 76 dB, which is very, very good to see. If you remember from like the first measurements that I said that like we're gonna be aiming for something like minus 66 dB, everything below minus 66 is very, very good performance. So in this case, basically this amplifier is everything below 66, which is amazing to see. So we have 77, something like that. We have a little scoop out here. So this basically means that this amplifier performs its best, like its absolute best, between 10 watts and 20 watts of power output. What does that mean? This is basically mid-bass on the normal listening levels, not pushing it too much. But if you push it, if you give it 30, 40, 50 watts, up to 100, because it is still the cleanest, close to up to 100 watts, because here we have this distortion starts to rise up, and we have 98. So basically up to 100 watts, it's super, super clean, like minus 64 dB, which is amazing to see. This performance for me is amazing. Just for comparison, I have this one. So this is the R500 DSP amplifier that I tested before, the small one, the 4-channel amplification and 6-channel DSP. And this one measured good as well. So it measured minus 69, close to minus 70 dB. However, the output power is, you can see, it's like up to 11, 12 watts. So like just for mid-ranges and tweeters, as I mentioned. However, this one is much lower than that. And the best thing is, if you remember the Senopo DSP that I tested. So these are the measurements from the Senopo DSP, but not the amplifier, but the actual RCAs out, so pre-outs. And this DSP measures minus 76, and basically, where is it? It's almost the same. So basically what's happening is this Alpine amplifier itself has the same distortion, the lowest distortion, as the Senopo DSP on the pre-outs. Imagine that, an amplifier measuring as a DSP. Now, granted, this Senopo is a budget DSP. We saw how Helix measures, because Helix measures down to 100, which is like all the way down here. But for an amplifier, for me, it's bloody amazing. If we have a look at percentage, we have 0.015. wow. For me personally, it's just wow. Everything is below half a percent, below 0.05%, and then it just goes up, but it's still everything below 1% is just amazing performance. Now, as mentioned before, with this amplifier, I was testing 2-ohm performance versus 4-ohm performance, because it is interesting to see how THD differs with different load. So this was the 4-ohm, and again, I'm going to repeat myself, went down to minus 76.8. Now this is the 2-ohm. And with 2-ohm, we can see the difference is that THD rises, but not that much. We have much more power, obviously, but THD goes up 76, 71. So like 5 dB, only 5 dB more THD we have. And if we have at 1%, again, have a look at 1%, we have 165 watts of output. So 175 it should be. So again, just because of the voltage, because this is 14.4 and I was measuring at lower voltage, so we can expect that it's gonna hit its target below 1%. But in 2 ohms, 140 watts, it's so clean, 0.1%. Wow. Where is it? Yeah, so percentage wise, yeah, it's a bit more. But what's interesting is the profile slightly changes. So 0.01 and we go up to 0.02. So like, I want to say double. The distortion increases twice, but it's like percentage is very, very small. It's still small. Amazing, amazing to see. Now let's have a look how the THD distortion varies depending on the frequency, which is this one. And we have absolutely no dependency on the frequency. X is flat, totally flat, minus 74. So this was done at 5 watts, which is slightly higher, which is here, 5 watts. So it's not the best performance, because the best performance is like 10 to 20, but I was testing this at 5 watts. So at 5 watts, we have minus 74 dB, but it's absolutely flat. We have some harmonics here, but those harmonics are second, yeah, so THD and second harmonic. But again, those harmonics are way below the actual noise level. So it's the THD in this range is influenced not by harmonics, but the actual noise, which is amazing to see. The harmonics, as you can see, they're much, much lower than that, but it's absolutely flat. Stepping down the load to 2 ohms, we have slightly higher, minus 71, but again, amazing, amazing performance. Percent 0.02. Okay, multi-tone. The thing is, like, with this multi-tone, if anybody can comment below, because I personally don't know how to interpret this. We can see like it's low, minus 71, whatever, so below minus 66 here, all the way up to what, 15 watts. But like, I personally don't know how to interpret this graph. I just see that it's low, which is good, I guess. Now, what I did is I did a sweep. So let's go here, the measurement number 6, and this sweep, since I measured on 96K, I did the sweep from 20 all the way up to 48 kilohertz. So what I'm going to do now, I'm going to try to zoom in. So we can see that, so this is 1 dB scale. At the bottom end, we're going to ignore these wiggles, because these wiggles are because of the sampling rates and stuff. It's supposed to be flat. But the frequency response, we see it at 20 kilohertz, we are down by half a dB only, 0.6 of a dB. At 10 kilohertz, we are down 0.2 dB, which is literally nothing. And like, because these amplifiers, the Alpine Type X, they have a high res sticker, so they're supposed to play high. But like, we know that all amplifiers do play high. We have something happening here at 37 kilohertz, but it plays all the way with no problems, no issues. And again, 20 kilohertz, we have 0.6 of a dB down, which is very, very linear. So like these amplifiers, they don't have any character because they play flat. So nothing is accentuated, nothing is like, there's no roll off at the bottom, at the top end, because like this half a dB roll off at 20K, it's not a roll off. It's just, it's flat. It's amazingly, amazingly flat. Okay, after this, let's have a look at these ones. So this is 1 kilohertz tone at 5 watts. And from this, the only thing that I can see is a few harmonics, which is the second harmonic is the prominent one. And then we have third, fourth, and fifth. So from this is amazing. I don't know, to me it looks very, very good. The second harmonic is like minus 80 dB. So this is on dBr relative scale. So minus 80 dB, the second harmonic. And again, we know that even harmonics sound better than odd harmonics, because on some amplifiers, you might see the third harmonic predominantly rising up, but on this one is the second one. So if this would pop up in like, if you would hear it, this distortion would ideally sound pleasant. I want to use the word. And on this we have THD plus noise minus 73.9, which is again way below 66. Amazing. If we add the 2-ohm measurement, which is number 9, so yeah, on 2-ohm we see that we have a bit slightly higher floor noise. And again, as I mentioned, this third harmonic, look at third harmonic, it pops up. So on 2 ohms, the third harmonic is more predominantly. So if you can hear, if you're gonna hear this by some chance, it's not gonna sound as nice. So I don't know if we can make a conclusion that just for this amplifier, running on 2 ohms, it's not going to sound as nice as running on 4 ohms. But again, it's just in theory based on some assumptions. I didn't do any like listening test 2 versus 4. Maybe I'm going to do it in the future, but yeah, it's just my assumptions. And multitone, 4 ohm multitone, we have everything minus 90, 192, and we don't see any issues all the way down to like 40 hertz. And then here is again, I'm not sure how to interpret this, but like on DSPs and especially on Helix DSP, you can see that this is rising up with more stuff happening at the bottom end. But this one all the way down to 40, picture perfect. Now if we step down to 2 ohms, the only difference is higher floor noise. Everything else is identical and the same. Yeah. And what I did is just very quickly to double check the channels to make sure that all of them are playing kind of the same. So that's channel 1, channel 2, channel 3, and channel 4. And we can see like everything is overlaying. Exactly the same performance, no issues at all. So I just very quickly added the THD and we have 75, 75.4, 75.1, 75.3, which is like identical. What I can see here is like this third harmonic. So on some channels, like the third channel, the third harmonic is the lowest. On channel number 4 is kind of almost the same as the second one. So again, channels, yeah, these all three are the same. They're not identical, but they're very, very, very close together. And like, you won't be able to tell the difference between the channels. So this is pretty much it. One more measurement that I did is the crosstalk. Now crosstalk is measured between the channels. So what I did is I was playing only one RCA on one channel, let's say channel 1, and I measured the voltage like a normal voltage, whatever, and then without playing anything else through any other channels, I checked the voltage on the next channel, which is number 2, and I had like these numbers: 13.5 volts on channel 1 and 0.01 volt on channel 2. And if I use just any kind of calculator online, I found it on this web, that translates the voltage difference into dBs, into decibels, and I got 62 decibels. Now, I'm not going to trust this number because 0.01 is an error of margin for my multimeter, because it is quite cheap thing and it's not going to be 100% accurate at these low voltages. So but we still have 62 dB. The thing is, like, I didn't check how big or small crosstalk is good or bad, so I have absolutely no idea. I will need to dive deeper into this. However, we have 62 dB. Few measurements, just few, because I kind of narrowed it down which ones are the most important ones, and for me personally this one is the most important one. And we can see amazing performance from this amplifier. Now the main question is how the other ones are going to measure against this, because I would expect the older amplifiers will have slightly worse performance. As power wise, that's a guarantee. The old amplifiers, the V12s, come on, nobody's gonna do 100 watts into per channel. But THD performance wise, it's gonna be very interesting to see. So yeah, stay tuned for the next videos, and thank you very much for watching, guys, and I will see you in the next one.